Hi students, welcome to today's video. Today we are going to start the chapter 2, which is number system. So students, number system is implemented in order for counting purposes mainly, isn't it? For example, if you want to count how many students are there in a class, or how many people are attending a party, or how many buildings are there, in order to count things, we are using number system. In early days, we were used stones, pebbles, then our fingers for counting, but that methodology was not sufficient. So that's why number system is implemented. Okay, isn't it? So that number system means set of values to represent the quantities, isn't it? As I said, number of students, number of buildings, number of people attending a party. Okay, and there are different types of number system: decimal number system, binary number system, hexadecimal, octal, and so on, isn't it? Every number system has a base. Okay, so every number system has a base. If you consider decimal number system, for example, decimal number system is 20 is a decimal number, isn't it? Then 10,299 is a decimal number. Okay, so base of a number system means how many digits are used in a number system, that is known as its base or radix. See, in decimal number system we are using So here, how many digits we are using? We are using digits such as 0, 1, 2, 3, 4 till 9. So if you count these number of digits, if we count these digits, so the total number will be 10. So we can say the base or radix of decimal number system is 10. So that is known as base or radix of a number system. Okay, students. Then the first type of number system which we are going to discuss is decimal number system. So as we said, the base of decimal number system is 10 because it has 10 digits starting from 0 till 9. Okay, so if you consider a number such as let's say the same example given in the textbook, we can consider 256. Okay, so 256 is a decimal number. So this decimal number, the value of this decimal number depends on three things. Okay, which are these things? It is given here: the face value of the digits, then the base of the number system, then the position of the digit in the number system. Okay, so here the face value you can see 6 is the face value, 5 is the face value, 2 is the face value. Okay, there is another option, another thing which is positional value that we can discuss. Okay, then if we want to get the positional value, so the positional value is 10 raised to 0 here, 10 raised to 1, 10 raised to 2. So how can we get the value of this one? So that we can get like this: 2 into 10 raised to, what is the positional value? 2, then plus 5 into 10 raised to 1, then plus 6 into 10 raised to 0. So what is the value? 2 raised to 10 raised to 2, that is 100. Okay, 100 into 2, 200, plus 10 raised to 1 is 10, 10 into 5, 50, isn't it? Then 6 into 10 raised to 0, 10 raised to 0 is 1, 1 into 6, 6. So the sum of this value is 256. That's how we are getting the value of a number. Okay, so I hope you could understand. This is the positional value, this is the face value, and 10 is the base of this number system. Okay, and if you consider the LSD and MSD, this is the MSD or most significant digit, and 6 is the LSD, least significant digit. Okay, we can explain some more examples. So we can take this example 1225. Okay, so this is units, tens, hundred, thousands. This is the positional value. Okay, we can say the positional value. So this digit represents that positional value, isn't it? That digit is in the correct positional value, which means 5 is in the positional value units, then tens, then hundreds and thousands. Okay, and so I hope you could understand what is decimal number system. It's already familiar for you, isn't it? Then next we are going to discuss decimal number system. Decimal number system, you already from the smaller classes you might have learned zeros, ones, combination of zeros and ones. This language only a computer knows, okay, or computer can understand this language. So a binary number means 1011, okay, or 00100011. This is an example of binary number system. So what is the base of this binary number system? We are only using two digits, which are the 0 and 1. So its base is 2. So base or radix of a binary number system is 2. Okay, so next we can learn how to convert decimal into binary number system. Let's take the same example, 321. Okay, we need to find out its corresponding decimal number. Okay, before that we can just convert 10, the decimal number 10 to the 10. We need to find out the decimal number, we need to convert decimal number into binary, or we need to find out the binary format of this decimal number 10. So we need to follow some steps. Which are the steps to follow? The first step is divide the given decimal number with the base 2. Why we are dividing with the base 2? Because the base of binary number system is 2, that's why. Then write down the remainder and divide the quotient again by 2. We have to write the remainder here and again divide the quotient. We are getting the quotient, we will write the quotient here. Okay, then repeat the step 2 till the quotient is 0. So until we get quotient as 0, we have to continue the division. Then write the remainders obtained in each step in the reverse order to form the binary equivalent of the given decimal number, that is placing the least significant digit at the top and most significant digit at the bottom. So let's see how to perform that division operation. Okay, so we are going to divide with the 2, then we can do like here 10 2. So how many times? 5 times. What is the remainder? 0. How we got the remainder? See, this is the dividend. Okay, divisor is 2. So 5 into 2, which is 10. What is the remainder? 0. Already know. So 0 we write here. Then we will check according to the second step. Okay, third step. Repeat the step 2 till quotient is 0. So quotient is a non-zero value. So we need to repeat the division again. So 2. So how many times? 2 times. 2 into 2, 4. So 5 minus 4 will be 1. 1 is the remainder. Then quotient is a non-zero value. Again we need to repeat the division. And how many times? Only one time. Remainder is 0. But here what happens? Quotient is a non-zero value. So again, how many times? 0 time. Then remainder is 1. So we got the remainder as 0. So we will stop from here. Then we will take these remainders are the as the corresponding binary. Then according to the last step, placing the least significant digit at the top and the most significant digit at the bottom. So what we have in bottom, that is the MSD. What we have in top, that is LSD, least significant digit. So MSD we are writing at the left side, which is, so we can write this one here, then followed by these values. So next is 0, then okay, the next is 1, then the last digit, which is LSD, that is 0. So this is the corresponding binary number of the decimal number 10. Okay, let's check whether it is right or not. We got 1010 as the number. So it is actually the binary number represents a code 8421. Okay, as it is increasing here, like 0 1 0, it will be 16, 32, then 64, like that it will be increased. Here we have only 8421, only 4 places. So where there is 1, we will add that 8. Then where there is 0, we will add 0. Here it is 1, so we have to add 2. Then here it is 0. This is a simple method in order to check the output, which is not given in the textbook. So I am just adding an extra information. So here it is 0. So what will we do? 0. So 8 plus 0 plus 2 plus 0, which is 10. So if it is matching with the correct decimal number, that is, this one is the correct decimal of, sorry, binary of this decimal 10. So that's how we can find out the we can get the result. Okay, then so this 25 and 321, I think you can you can find it yourself, because I already explained one example. You can watch it again. Okay, then binary to decimal conversion. Okay, so we can check how to convert back, means from binary to decimal. So we can, let's see the steps. Multiply each binary number with its positional value, which is in terms of the power of 2, starting from the extreme right digit, increasing the power one by one, keeping the base fixed as 2. Calculate the sum of all the products to get the decimal number. Okay, let's see. Suppose here the same example we can take, isn't it? 1001. Okay, so this is the, why we are writing like this, in order to represent it as a, in order to say it as a binary number system. Okay, so which means its base is 2. So its positional value is 2 raised to 0 here, 2 raised to 1, 2 raised to 3, 2 raised to 4, like that. Okay, so as I said earlier, so 1001, its positional value is 2 raised to 0, 2 raised to 1, 2 raised to 2, 2 raised to 3. What is its result? 2 raised to 0, 1, 2 raised to 1, 2, 2 raised to 2, 4, 2 raised to 3, 8. So as I said only, isn't it? So this is its positional value. But we will, how can we convert this the same way as we have done? Okay, let's see how. So students, we have 1001. So we will take the this we will start according to the rule, starting from the extreme right digit. Extreme right means the LSD, least significant digit. So we are taking the first one, then 1 into 2 raised to, its 1 will be multiplied by its positional value, which is 2 raised to 0, then 2 raised to 0, plus, then take the next one, which is 0, 0 into 2 raised to, its positional value is 2 raised to 1, then plus next digit is 0. So 0 into 2 raised to, its positional value 2 raised to 2, then plus the last digit. Here in this case this is the last digit. So 1 into its positional value 2 raised to 3. So we will evaluate this. 2 raised to 3 is 8. So 8 into 1, 8. Okay. Then 2 raised to 2 is 4. 4 into 0, 0. Then plus 2 raised to 1 is 2. 2 into 0, 0. Then 2 raised to 0 is 1. 1 into 1, 1. So what is the corresponding decimal number? 8 plus 0 plus 0 plus 1, which is 9. Okay. So the same output we got. Okay. So this is how we can convert binary into decimal number. So I hope you could understand. So suppose there are several ones. Suppose 10, 10, 10, 10. What is its face value? Same, 2 raised to 0, 2 raised to 1. 1 will be increased. Okay. In each position, 2 raised to 3, 2 raised to 4, 2 raised to 5, 2 raised to 6, 2 raised to 7. How can we perform this? 2 raised to 0 will be 2 raised to 0 will be 1, 2 raised to 1 will be 2, 2 raised to 2 will be 4, 2 raised to 3, 8, 2 raised to 4, 16, 2 raised to 5, 32, 2 raised to 6, 64, 2 raised to 7, 128. So how many values we will add? Simply we can where there is 0 we will write in that places 0 only. Where there is 1 we will write its corresponding positional value. So here in this position it is 1, so we will write 128 plus, here it is 0, so instead of 64 we will write 0. Here it is 1, so we will write 32 only. Then here it is 0, so instead of 16 we will write 0. Then here it is 1, so we will write 8. Then for this position it is 0, so we will not write 4, we will write 0. Then here it is 1, so of course we will write 2, and at last also it is 0, so we will add 0 here. Okay, then 128 plus 32 plus 8 plus 2, that will be its answer. Okay, let's see what will be the answer. 40, 168 plus 2, 170. Okay, 170 will be this is the corresponding decimal number is 170. Okay, so this is how we can convert binary to decimal number system. So students, the next one is hexadecimal number system. So hexadecimal number system means this number system contains 16 digits. Okay, so what is its base? 16. How many digits are there in a number system? That is known as its base. Okay, like a decimal number has the base 10, binary number system has the base 2, then hexadecimal number system has the base 16. Let's see which are the numbers. So usually to represent 0 to 9, we are using the same digits like in decimal number system, which are 0, 1, 2, 3, 4, 5, 6, 7, 9. Okay, 10 will be represented by, okay, 10 will be represented by A, then 11 B, then 12 C, then 13 D, 14 E, 15 F. Okay, so hexadecimal number system contains digits from 0 to 9 and letters A to F, only capital letters, there is no small letters. Okay, this number system also known as hex, simply HEX. So total how many digits are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So including F, there are 15 digits. That's why its base is 16. Okay. Then we will write a hexadecimal number system is like this, like 9A. Then we will write 16 as the subscript. Why we are writing 16 as the subscript? In order to say it's a hexadecimal number system, we can understand from the 16 that it is a hexadecimal number system. So it's also known as hex. So let's see how to convert hexadecimal number system into a decimal number system. So students, we have learned how to convert a binary into decimal and decimal to binary. Okay, so here 3b, here 3b means its positional value. The positional value of the LSD, least significant digit, is 16 raised to 0, and for the next digit 16 raised to 1. Okay, if there are multiple digits like 4, 3, A, F, what is its positional value? For F it is 16 raised to 0, for A 16 raised to 1, for 3 16 raised to 2, for 4, for the digit 4 16 raised to 3. Like that, the power of 16 will be increased from right to left. Okay, that is its positional value. Then let's convert this 3b, hexadecimal 3b, into its corresponding decimal number. Okay, so we can write here. Okay, so b multiplied by its positional value, which is 16 raised to, sorry, not 10, it will be 16 raised to 0. Then we will take from the LSD, or the rightmost digit. Then here the LSD is b. Then we will take the next one. Okay, which is 3 into 16 raised to 1. Okay, then what is the let's say actually the real value of b? We can just write the real value of b, which means after 9 we will use a for the value 10, then b for the value 11, then c 12, d 13, e 14, F15. Okay, so instead of B, which value we can write here? 11. 11 into 16 raised to 0 is 1. Any number raised to 0, that is 1, isn't it? So that is 1, then plus 16 raised to 1, which is 16 only, then into 3. So we can solve 16 into 3 first, which is 48, then 11 into 1, 11 only. So what is the final result? 59. So this 59 is in decimal format. So we can write 59, the subscript will be 10. So this is how we can convert hexadecimal into decimal. So you can refer this 4D2 yourself. It's very simple, isn't it? Then we can learn some binary arithmetic operations such as arithmetic addition, multiplication, and subtraction. Okay, in this time we will not learn arithmetic division operation. Okay, that is skipped. So students, you already know that computer can understand only binary numbers, which are zeros and ones. So sometimes we may need to know how to add binary numbers. Okay, so let's here you can see just a table. Okay, means how to add 0 0 0 1 1 0 and 1 1. Okay, so when we add 0 and 0, the result will be 0. Then as like a simple like adding a simple decimal number. Okay, how we are adding a simple decimal number, the same will happen for binary addition. There is no change. Only uh, we have to understand, or we have to notice when we add 1 and 1. Okay, when we add two binary 1, we need to be careful. Okay, so let's see this table. 0 plus 0 will be 0, 0 plus 1 will be 1, 1 plus 0 will be 1. Okay, as like a decimal. But when we add two binary ones together, the result will be 1 0. Okay, you don't consider it as a decimal number 10. It's a binary number 1 0, not 10. Okay, so if we add any two values, 1 0 0, then okay, let's 1 0 0 0, then 1 1 1 1. How can we add? According to this table, 0 plus 1 will be 1 only. 0 plus 1 1, 0 plus 1 1, 1 plus 1 will be 1 0. So this will be the answer. Then if we consider another example, 1 0 1 0, then again 1 0 1 0. We have converted this 1 0 1 0 in the previous example into decimal, isn't it? What is the corresponding decimal number of 1 0 1 0? So let's find. So this is, if you write 1 0 1 0 in binary format, its positional value is 2 raised to 0, which is 1, then 2, then 4 and 8. So 8 plus 2, which is 10, isn't it? So its corresponding decimal number is 10. So if we add 210, which means 210 in binary, the result will be 20. That we know, isn't it? So we need to so what we want to find out here, we need to find out the corresponding binary of this 20 by adding these two binary numbers. Okay, let's check. Let's see what is the result. 0 plus 0 will be 0. Okay, then 1 plus 1 will be 1 0. So 1 0, which means this 1 will be the remainder. Okay, so here it is written, while adding 1 plus 1, the output will be 1 0, where 0 is written under the same column and carry over 1 is shifted to the next place. So this 1 is the remainder or carry. Okay, so we will consider it as carry. So carry will be added to the next column. So here 1 plus 1 1 0. So 0 we will write here. Then that remainder or carry, the carry will be added to the next column. So next column is this. So we can write that one here. Okay, so the remaining one, which is carry. So then we will add this column 1 plus 0 plus 0, which is 1. Okay, then one more column is remaining. So 1 plus 1 1 0. So we got the result as 1 0 1 0 0. So we need to check whether this is the correct result or not. isn't it? So what we will consider? We will consider its positional value, which is 2 raised to 0, 2 raised to 1, 2 raised to 3, 2 raised to 4, 2 raised to 5. That means 1, 2, 4, 8, 8 and 16. Okay, where there is 1, we will take that positional, its corresponding positional value, and we will add. We will not consider the positional value of zeros. We will consider the positional value of ones, and we will add that positional value. That sum will be the corresponding decimal number. So here, if you consider only two positions, only in two positions we got 1. So we can take its corresponding positional value, which is 16 and 4. So 16, here 0, so 0. Here it is 4, sorry, here it is 1, so we need to add 4. Here it is 0, so we need to add 0. Here it is 0, so here also we need to add 0. Then 16 plus 0 plus 4 plus 0 plus 0, which will be 20. Okay, so by adding decimal number 10 and 10, we will get the decimal 20. So we got the correct answer, isn't it? From here it is clear that we got the correct output. So here the correct decimal number, the sum of these 1010 and 1010 is 10100. This is the right output. Okay, I hope you could understand the addition of binary numbers. Then we can add one more, 11111, the same example, 1011. Okay, so 1 into 1, 0. Then that carry will be written in another in the next column. Then 1 here, 1 plus 1, 10, isn't it? So that 10 will be added with okay. So students, see 1 plus 1, 0 with the carry 1. That carry we will write here. Then 1 plus 1, again 10, isn't it? So again 10 means again 10. Then remaining 1, there is 1 in another 1 in that same column. So that 1 will be added with here. So 1 1. Okay. So this is the carry 1 again. This remaining 1 we will write here. Then this carry 1 goes to the next column. Then 1 plus 1 is, that is 1 0. So 0 is writing here. Then the remaining 1 goes to the next column. Then 1 plus 1, again 1 0 plus 1 1 1. Then carry will go here 1 0. So the result is 1 0 1 0 1 0. Okay, this is how we perform binary addition. Then next we are going to perform binary subtraction. Okay, so here is the table for performing binary subtraction, as you can see here. Okay, so 0 minus 0, 0, 1 minus 0, 1, 1 minus 1, 0, 0 minus 1, 1. So that is the rule we need to understand or keep in mind to perform binary subtraction. So the result we can perform this one, 1 1 1 1, 1 0 1 0. Okay, so 1 minus 0, 1, isn't it? According to this rule, 1 minus 1 is 1 minus 0 is 1. Then 1 minus 1 will be 0, isn't it? Then 1 minus 0 will be 1. 1 minus 1 will be 0. So this is the result. Okay, then let's take another example, 1 0 1 0 1 0 1 0. Okay, we already know this is the third time we are writing 10 10. This is, you already know, the decimal number of 1010 is 10. So we are going to subtract 10 from 10, means 1010 from 1010. So 10 minus 10, 0 should be the output. So 0 0 0 subtracted from 0 will be 0. 1 subtracted from 1 will be 0. Then again 0 and 0, we got 0. Okay,